That's what I'm gonna try and do. That's what I'm
I mean, I just touched the bag. It slipped right into the sand.
like shove the food in his shoes.
What? It's comfy.
Okay, so we start the simulation by creating a part. We know that we have different modules here. So part, property, assembly, step, load, mesh, and job.
Yeah.
So we start with module part, the first module, you create part icon to make a part here. So use this icon here. In the create part window, you can change the name of the part. That's up to you guys. And since we are modeling a two-dimensional case, we just click on 2D planar, and it's a deformable model, and we are using wires. So click on wire. The approximate size you can depends on the model size. So
transfer over to this now. We're just doing work over here.
So in case that we have a model like this,
Focus.
one boundary condition here, one boundary condition here,
It's a horrible idea.
and
Oh yeah.
a load here, and
I guess you need to right?
one load here.
Beams going every which direction. Absolutely failed like boss.
And the cross-sectional area.
Are you doing talking to your sister? Oh, she's cute. Oh. Your sister already. Oh, she's cute? I know. Teagues his life.
Okay. So for the units, you guys, some of you asked me a question about the unit that you're going to use. So Abaqus does not ask you about the exact unit. So are you using meter, are you using millimeter, or anything? What Abaqus is understanding is the unit of length. So that's up to you guys that how to model it. You have to choose a set of units for you and just you stick to it. So some examples. The easiest way is the metric unit. So in that case, all the inputs are metric. So for lengths, we simply use meter. For cross-sectional area, we use square meter. For, let's say, Young's modulus or a stress, it's Pascal over square meter. Newton over square meter or Pascal. So of course, for your force, you have to use Newton. For pressure in loading, you use Pascal. For case you want to use millimeter, the cross-sectional area has to be millimeter square. So here for load you use Newton. For stress is Newton over millimeter square or megapascal. The pressure is also megapascal. So Abaqus does not ask you if, when you're modeling and you say the length of this part is 10, you don't mention if it's 10 millimeter, 10 meter, or 10 micrometer. That's up to you guys. All Abaqus understand that it's the unit of length. Okay? So in this case, I'm using this unit area, so I'm using millimeter. The size of my model is 100 millimeter almost, so I just give it 400. It doesn't really matter, it's just an approximate size of the model. So here I use these commands, create line command. And you can start from somewhere. I start from 0 and 0. Click. The next part is 100. So this is my second point. I give it 100 and 0 down here. The new coordinate system. The next point is here, which is 100, 100. So of course, the fourth point is 0 and 100. And the last point you just simply connect it. You have two other members, so 1 and 2. So this is the model. If you have any doubts about the dimensions, you can simply check the dimensions using these tools here. Add dimension. So beginning and end of the member, and it says 100. So I know that I get it correctly. You can also check the other direction. It's 100, so I know that there is no problem with the dimensions. So I click on this cancel procedure, and finally done. This is my model. So everyone's good? For those who are working with a laptop, everyone created a model so far? Okay. So we go to property. Now we want to give it mechanical properties. So we click on create material here, and mechanical, elasticity, and elastic. So we don't change anything here. We just input the Young's modulus and Poisson's ratio. Was there any question?
Sorry, how did you get to that screen?
So I close it. So in the module, property module, okay? This icon on the top left, it says create material. You click on it. Then you can change the material name or not, that's up to you. So we go to mechanical because we want to give it mechanical properties. Then elasticity because it's going to be an elastic material. And with the options that we have in elasticity, we choose elastic. So the Young's modulus. So let's say the Young modulus that I have in mind is 100 gigapascal, and the Poisson's ratio is 0.25. So I know that all the properties with the properties as known as Pascal or force divided by square lengths has to be in Remember, everything, stresses, pressure, or Young's modulus. When your unit area is Pascal, since we are dealing with these units here, we have to give it as megapascal. So 100 gigapascal is actually 10 to the power of 5
in general, I know.
megapascal. Okay? So I give it
Elasticity.
1 E5.
So if you were to use millimeters and kilonewtons, then you don't have, you can put 100 EPA, right?
No, if you're using kilonewton, then it would be, yes, kilonewton gigapascal. Yeah. Okay. And the Poisson's ratio is 0.25. When you enter the mechanical properties, you simply click on OK. So everyone got the material properties? So the next part is creating a section. So we click on this icon here, the second one from top, and it says create section. So we click on it, and we choose beam, and from the type we choose truss, and continue. So since we already defined one material properties, we have just one option here. We don't change it. And it asks for cross-sectional area, which we have to give it in millimeter square, which is 0.001. And there is nothing else to change, and you just click on OK. The next part is assigning a section to the model. So the third icon from top, you click on it. Here we need to choose all the sections that we want to assign, we want to assign the section to. And since all of them I consider the same cross-sectional area and material properties, I simply select all of them, click on Done. And I only have one section defined here, so I don't have any other options, and click OK. So everyone's good so far? Yeah.
Did you get me flashing the camera?
No. All I have in here is like the top of like Ashley's ponytail.
I get your head.
Too bad you're not in it at all.
Is this the viewing?
So I'm filming the entire thing.
We're going into the depth of the
And then if I can, I'll just send it to everyone.
I don't have enough space on my phone, so I just have to keep taking Snapchats and posting it to my story.
Yeah. Let's watch that.
You turned it on? No, you didn't. No.
I thought it. I'm pretty sure I videotaped my dick passing through my shirt.
I'm not going to.
You could also not.
You can
video
stop
this
it right now.
second.
Yeah, here we go.
You still filming, you?
It's a wild ride. It's all black.
Just unlimited storage.
I'm not that good.
Oh.
I did a story of what it would be like to pass through my shirt.
How you know?
Yeah.
It was black. I didn't know how the boat
Sorry, inappropriate. Ooh, Snapchat.
No, it's a video. Don't watch it.
You grabbed someone's phone, took a video of your shirt, and they're like, oh wait, something inappropriate. Jesus.
Maybe you have a story.
Yeah.
I don't have a story.
I don't mean it was someone that took me once, and I was like, wow, that's really cool. Should I do more Snapchats? I don't have any more.
Spring break!
What?
What, you want me to show my nipples too, like Chase?
You're welcome. People like the story.
How do I see it? Oh, it's at the top.
Look at that, it's a good story.
You just cut. that bitch.
Is it actually like, is it like telescopic?
No, it's
Do you have
it's
stories?
like this big, and you just like yeah.
Yeah, that's magic.
Instead of like the 3D.
I don't think myself is like that, but I can see that being useful.
That looks funny. I remember like when I go to like a friend. Once in a while, we take your house.
Not really useful.
What is this? What is there something like in the background? You get
Let's say if you're traveling around.
I think we're going to visit.
Yep.
Usually it's just like before no. We'll look one up. Picture of everyone. I think it is because
You're real
they're all
hair. You go back. I like it.
Thanks. That would be cool.
No, I just know what it's like your wig is growing out. You know, showing its gas station on Main Street.
Really appreciate that.
It was super. But it was a good wig. I told you day one.
Yeah.
Day one.
I went shopping.
Who was there?
This is another story of 39
And I bought like
I was playing.
Once you die, it's a wig. Right?
Yeah.
Because wigs are very human hair.
Where's the one that I bought?
Do you want a selfie?
No, there's another one out there. 'Cause I did one of my kids.
I'm not.
I can get every
I'm like, okay, wait.
Why?
I have a plethora of space.
So, the veritable cornucopia.
Yeah. Gigas of space.
So much. Oodles. Apes.
Yep.
Yeah, neither was I until I got to university. I was like, I can
No,
get
I'm in it.
No one knows me.
Am I in it to win? I'm just like in it. Good.
Yeah, nice headband.
I make the pussy tattoo and the headband.
Thanks.
Do you guys know that song?
Go to bed.
Doom, 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 doom,
Yeah, man, play this at my funeral.
Already got one roll from my left
Has anyone
lane.
noticed that
We're gonna be a happy about
have
this.
really similar faces?
Oh, he's dead. Okay.
Who?
Curry and Nate Lyon have really similar faces.
Yeah. You guys might be brothers.
Whoa!
Probably not.
I'm pretty sure I'm. Never mind.
Worrying me.
Already? Okay, I'll look up the lyrics and I'll sing it for you.
I think we're actually distant cousins. What's your last name again? Oh, same.
I think that Nate Lyon is just a character that Curry plays. Because I've never actually seen them in the same room together. It's a bit suspicious. Oh shit, well there goes that theory.
That's my dog.
First time ever.
Nate Lyon.
It is Nate Lyon.
I'm not in my Facebook. I might even give myself that name.
Change your Facebook name to Nate Lyon.
No.
Just do it.
Nathan, can I borrow your phone?
I'm not Shia LaBeouf.
Come on.
I
No,
log
you're
out
not
the app
Shia
every time
LaBeouf.
you use
You're
my
Nate
Facebook.
Lyon.
You log out of Facebook?
Yes, I do log on the Facebook app. Because what do you jerks
Already got one. Rolled
People
up
are
in
gonna
the
need
left
this.
hand.
They don't need it in the last 5 minutes.
Pussy on my mind, tighter than a
It's just
headband.
entertainment for them.
Everyone
Cushion my lungs.
Yeah.
Oh my god, it's so good.
Okay, let's continue from the modules. Now we select assembly. So we go to the assembly module. So here we click on this icon, top left. It says create instance. And we have two options. So let me explain the differences between these two options. So for the first one, it says dependent. Actually, whatever you do to your model, it affects the original part that you just created, okay? But in the second option, it just creates a new instance from your model, and whatever change that you make to it, it will make those changes to the instance, not the original model. So it just In your case, which is a really simple model, it doesn't really matter which option you choose, but I normally choose independence. Okay, so choose independent, click OK. And we are done with assembly. The next step is the module step. The fourth module from top. So here we need to define a step how to run the model. So we simply click on create step. The icon is top left. You can change the name or keep it. We don't change anything here, so just make sure it's static general and click on continue. Okay, so there is not, because of your license, there is not much to change here. Just simply click on OK. So everyone's got it so far? Everyone created a new step? Okay, so the next step is the module load. We don't have any interaction here, so the interaction is basically when you have two different objects having contact or something. You don't have it. So from module step, we jump to module load. So just click on load. So in this module, we first define the loading. So I click on this icon top left, it says create load. We click on it. You have different options, moment, pressure, but we want concentrated force. So we does not change anything here. Click continue. Okay, so it prompts you to select points for the load. So now I want to select a point. So I have 2 points, but I have to allocate them separately. So first I choose this one. When you select the point, it turns into red to make sure that you have actually selected the correct point. Then you can click on done at the bottom. So it's basically you have 2 options, CF1, CF2. So CF1 is X direction, CF2 is Y direction. Since my loading on that point is in Y direction, I put 10. But since its direction is opposite of Y direction, so I need to put -10. And CF2 is the amount of load on that point in X direction, so you can just simply leave it blank or put 0, it doesn't matter. And you click OK. Oh.
How would you edit a load if you put it in there wrong?
Yeah, so it's a good instance. So you click on the load manager, the icon on the right-hand side, and you see the loads that you've already defined. So you select the load, click on edit. So I was explaining we should put it in CF2 and I simply put it in CF1. So we remove it here and we put -10 in CF2.
Shouldn't it be -10,000 because it's 10 kilonewtons?
Is it kilonewton? Yes. Thank you very much. It should be 10,000. So we click on OK. And in order to create the other load, we can either click on create here, or again close it and go click on this icon here, create load. Because we have a second point to create a load. So click on it. Again, it's a concentrated force, so we keep it highlighted, click on continue, and now we select the other point. Down here, click on it, it turns into red. Then click on done. And so this load is in X direction and it's positive. So we simply put 10,000 in CF1. And click OK. So everyone's good so far? Everyone has created 2 loads and you can see it? Yeah? So now we want to create our boundary conditions. So we click on this icon, the second icon from top left. It says create boundary condition. So we click on it. From the types, we select displacement rotation, the second from top, and we click on continue. Okay, so this point is the first point that I want to put a boundary condition for. So I click on it, it turns into red, then I click on done here at the bottom. And the direction that I want to kind of fix is X direction and Y direction. I don't want any movement in X and Y direction. So when you check the box next to them, you see that a 0 appears, which means the amount of displacement for this model and this direction is going to be 0. Of course, you can change it to any value, and the model move them in those 2 directions. If you, let's say, put 1 after the simulation, that point moves in X direction with the amount of 1 unit length, whatever it is, 1 millimeter, meter, or whatever you have defined. Okay, so click on OK. The next point is here that I want to allocate a boundary condition. So again, I click on create boundary condition, this icon. And I choose displacement rotation for the type. And I will click on continue. So I select this point, turns into red, click on done. And the only direction that I want to close is X direction. And okay. So everyone's got it so far? Okay. The next part is mesh. So if you remember, I told you it's really important in Truss because in finite elements, generally the more number of elements is better. It leads to more accurate results, but not in case of Truss analysis. And why is that? Because if you break, let's say, this element into 4 parts and create an element for each part, then it would treat each part as a separate truss member, which is not what we want. So we make sure that each element, each member got just one element and one mesh. So in order to do that, I click on this icon which says see part instance. What it does, it asks you about the approximate size of elements in the model. So the top icon on the left, it says see part instance. So you click on it. So here it says approximate global size. I know that the dimension of each element here is 100, so the dimension, I need to give it something larger than 100. So I just say 500 or 600, something, so I make sure that the size of the element is larger than the size of a member. And again, for finite element, that is the opposite for other type of simulation. We always want the maximum number of meshes possible. Okay, so when I change the approximate global size to 500, you don't change anything else, and you just click on OK. The next part is, actually, in order to make sure you didn't make any mistake, you see these squares here. So it's showing you the node locations. So in case I've made any mistake, you don't change it. I just want to show you. So in case I put 10 here mistakenly, look how it looks like. And just by looking at it, you know that you've made a mistake, because between each two square you got an element, and that's not what you want. So that's a good way to figure that out, that you have made a mistake. Okay. So in the next part, I want to change the element type. So I go to this icon here. It's the fourth from top left, and it says assign element type. I click on it. I select all the members. It would turn into red. Then click on OK, on done. So the only thing I need to do is to change the family here to Truss. And then click OK. And the final stage is to mesh it actually. So you simply click on the second icon from top and left, and says mesh part instance. When you click on it, it asks you OK to mesh the part instance, and you click on yes. So basically you are done with modeling. We go the next step, the next module is job. So we click on Job Manager, which is the icon on the top right. A window pops open. We click on Create. And so here you can change the name of the job. I will change it to Test. And click Continue. So you don't have much options here, so you just simply click on OK. And finally, all you need to do is just click on Submit, so the analysis starts. So anybody who's not there has any problem? Anyone? Everyone's got it? Everyone's submitting? Okay.
So you're not allowed to use the optimization tool.
I don't even know what the optimization tool does.
Okay, so my analysis is completed. Look at its status here. It says completed. Everyone's got an error?
Mine's running.
Okay.
I don't know what it's running. Oh, completed.
Well, the computer that mine is running is a server, so.
Don't know why it's running. What's it running from? Oh, you're such a silly dog, AJ. You always count on me to say the worst things at the worst times.
everyone looks
Like a reality show. Angled.
so click on the results button here to see the results. So if you want to see what you have done, you can click on this icon. It says plot contours on deformed shape. So by just looking at the deformed shape, sometimes you can figure it out if you've made a mistake. So in this case, it looks okay, and yeah, the deformation scale is here, so it's really low. So what you see is a large displacement, and the amount of stresses are shown here, and it's in what is the unit for a stress? What is it? Yeah, what is the unit for a stress? So I see some numbers. What are the units? Pascal? Are you sure? Yes, megapascal. So remember, since we use this set of units, everything now that is related to Pascal is in megapascal now. Okay, so in order to verify your model, you have different options. Like I said, the first option is hand calculation. Not for large models, so if you do a simple procedure for a smaller model, you can just check it out and make sure if it's correct. The other system, which is a bit more complicated, is to treat your model as a cantilever beam. And put two different set of loading. So once you put loading like this, and treat it as an actual loading, and calculate the equivalent properties, and by equivalent properties I mean E times A, something like that, and then try to figure out the bending properties. So that's the other way, but like I said, since it's a bit complicated, it's not mandatory. Okay, so when you made sure that everything is okay, you want an output. So for the output, you can click on report here. And you have three options, X, Y, field output, and free body cut. I choose field output. So report and field output. In the variable and position, I choose unique nodal. And what I need from the simulation is the displacement. So I need U1, the displacement in X direction, and U2, the displacement in Y direction, and click on OK. Oh, yeah. So let's go there again. Report, field output. So in setup, you have different options, like the name of the output file. So let's change it to test, and with text.txt, so we can open it using Notepad. And here you can change the number of significant digits I put it to maximum, and that's it. Now I click on OK. So where did it go? It goes to the temp file, and it's normally, if you haven't changed the default, it goes to computer, C drive, and temp folder here. That's the default address if you don't change it when you're installing the software.
Do you have a variable click before you click OK?
Variables, yeah, U1 and U2. Yep.
I'll let you do your thing.
Okay, guys. So in your temp file, in your temp folder, which is normally in computer, C drive, and temp, you should see the name of the file that you just created. So I named it what? Test. Yes. Test.txt. So that's my output file. And from all the information here, I need this. The amount of displacement for each node, number 1, 2, 3, 4, 5, at direction of X and Y. Okay, but we need another file as an input for MATLAB, and that has been created automatically. What is it called? It's called the name of the job. So if you haven't changed it, it's job 1. It's here called job1.inp. If you change it, whatever, it's the new name. So I called my job test, and it's here, test.imp. It's my input file. We need these two files as an input for MATLAB. So the file that you just exported and the file with the extension of INP. So I just copy them somewhere on the desktop. Okay. So that's what you need to do in the Abaqus part. So for the MATLAB part, I just reviewed how we import these files into MATLAB. So if you guys have access to MATLAB here? No? Okay.
No.
Okay, so in MATLAB, like I said, I just reviewed the importing process. In the Home tab, you have an import data option here. If you click on it, it asks you for the address of the file. So you just, in your computer, I know that I put it on desktop, and I will start with my test.txt, the file that I created myself. Click open. Okay, so from the options that I have, I will change it to fixed width. Okay, so all I need is these data, right? So the node numbers 1, 2, 3, 4, 5, and the amount of displacement. So I just select this part. And for the sol imported data, I choose numeric matrix. And finally click on import. So since the name of the file that I imported was test.txt, it created a variable called test, and if you double click on it, you'll see that your data has been imported into MATLAB. So you can change its name to, I don't know, whatever you're planning to call it. I just call them display. So I need to now import the second set of files, which is the input file. So I just click on Home tab. The same process. Click on Import Data. I browse from my computer. I change the type to all files. And test that input here. So this time I choose delimited, and there is two parts that I'm interested in. The first part is under node. That what it is actually the coordinate system of each node. So it says the coordinate system of node 1 is 0 and 0, for node 2 is 50, 50, etc. So I just select this part. Again, I select numeric matrix and click on import. So I need to do the same process again. So if you look at it, it says, again, test. And if you double click on it, it is each node and its coordinate system. I just change its name, I rename it to coordinates. Again, I need to go through the same process. Click on Home tab, import. I choose the same file, test.input, and click open. Now I want the information under star element. So what is it? It is actually, it says element number 1 is the element between node 1 and node 2. Element number 2 is the element between node 2 and node 3, etc. So this time I choose these elements here, change it to numeric matrix, and click on import. So if you close the import window now, again there is a file called test, and I rename it to element. And these are the three variables you need to write your code and calculate a stress, a strain, or whatever you want. You can, that's all you need for your MATLAB code. So yeah, that's basically it. That was the Abaqus part. Like you see, it doesn't take, if you don't want to explain it or you don't stall, it takes like 10 minutes. And for MATLAB code, probably you have to, I don't know, half a day or a day to figure out the algorithm or how to calculate it and verify it. But once you write your code, that's it. You can use it 100 times, several times.